practice question set number 14. Number 1 says, a student uses a bar magnet to pick up a paper clip. The magnet causes what? What's the answer to this one?
C.
It's C. An alignment of the domains in the paperclip, which results in the paperclip becoming a temporary magnet. Remember, when we have a charged object nearby a neutral object, this is electric charges, right? It induces a temporary separation of charge, which causes the neutral object to be attracted to the charged object. When we bring a magnet nearby a ferromagnetic material, it induces a temporary alignment of domains, which causes the non-magnet to be attracted to the magnet. So that's what we have here. The answer is C. Number 2. Which of the following diagrams illustrates the magnetic field surrounding a bar magnet? This one is really straightforward. There's only one magnet in each of the diagrams. If there was 2 magnets, you'd have to look at whether the lines join up or not to determine whether it's attractive or repulsive. In this case, since there's only one magnet, you just have to look at that second thing that we talked about, and that is the direction of the magnetic field. It always goes away from north toward the south, so the answer is going to be C. You got to be careful here, though, right? It's an easy question if you're careful, but if you're not careful, it's so easy to put an answer like B, right? Or, because magnetic field lines, you look at this one, oh, look, it's going from north to south, right? So that's our answer, right? But if you don't look a little closer, you're going to miss the fact that that one's going toward the north and that one's going away from the south. So watch things like that. Okay, the answer is B for that one. Next question, number 3. It says 2 bar magnets of equal magnetic strength are placed as shown below. The point P is the same distance from each of the magnets. We want to find the direction of the magnetic field at point P due to the 2 bar magnets. Now, some of you may do this. Some of you may start drawing like a magnetic field like from north to south like this. Right? How many people did that? How many people did it that way and determined direction of the magnetic field? Okay, how many people did it this way, which is the way that I would do it? Just look at them independently of one another. Say the magnetic field goes away from the north. The magnetic field goes toward the south. Okay, the net magnetic field as a result of that goes somewhere in between. That makes sense? The answer for that one is D as a result of that. So how many people did it this way? Okay, looks like there's a question here. Did I make a mistake? The second one? Okay, let's finish this one off here. So this one is D, definitely. So you think I made a mistake on the second one? Yeah, it's C.
Oh, I think you said B.
No, I said B is, you got to watch out for B. You got to watch out that you don't pick B. We have a magnetic field in B that goes from north to south here, right? So that's a correct magnetic field there. But then if you're not careful, that you're going to miss the fact that this one is going toward the north, so that doesn't work. And this one is going away from the south, so that doesn't work. Okay? So all of these have things that you got to watch out for, right? But actually, D looks like the worst, right? It's like you look at this, oh, that's away from the north, good. Toward the south, good. Oh, but this one is from south to north, so okay, it's an easy question if we're careful, but if we are not careful, then we put B or D or something like that. Okay, last question, which I thought was a little tricky, is a Venn diagram. Remember we drew a Venn diagram showing the relationships between the electric field equations, the producer equation for the non-uniform, the producer equation for the uniform field, and then we had the experiencer equation. We saw what they had in common, what they didn't have in common as a result of that. This Venn diagram has three circles in it. You know that in a Venn diagram where they overlap, they have things in common. Where they don't overlap, they don't have that in common. So you can see that if you call this circle 1, circle 2, and circle 3, okay, 1 and 2 have this one in common, 1 and 3 have this one in common, 2 and 3 have this in common, and then 1, 2, and 3, all of them have 7 in common. And then number 8 means none of them, right? Okay, none of them. So what do we got here? Match the following numbers. Match the numbers of the regions in the Venn diagram above with the descriptions given below. We start off relatively straightforward, I think, can be directed toward the source. Don't look at the Venn diagram right away. Look at what we have. We have three fields: gravity field, electric field, and magnetic field. Which one or ones, independent of the diagram, okay, don't look at the diagram right away, just answer this question: which field or fields can be directed toward the source or toward the producer?
Gravitational.
Gravitational, yes. Always toward the producer, right? What about electric? Yeah? Toward a negative producer, away from a positive, but toward a negative. What about a magnetic field? Yeah, toward a south pole, right? Away from north, but toward the south. Can be directed toward the source? Absolutely, all three of them can. So this one would be option 7. This is the one that all three fields overlap in. Okay, can be directed away from the source. Electric field? Can be, not always, but can be. Magnetic field?
Yep.
Yeah. Gravitational field?
No.
No, gravitational field is always toward the source. So we're going to look at magnetic and electric field, and you can see that number 6 has magnetic and electric field in common. So we're at 7, 6. Is inversely proportional to the distance squared. Now, this is a tough one, but this is one where you've got to use this almost a strategy as opposed to your knowledge for this. And we've talked about this before, not this specific thing, but this strategy before. We know that a gravitational force is G m1 m2 over r squared. Sorry, the gravitational field, I should say, is Gm over r squared. Okay? So gravity is inversely proportional to the distance squared. Agree? Okay, gravity works. The electric field is kq over r squared. Is the electric field inversely proportional to the distance squared? Yes. Straight knowledge from what we've done, right? What about the magnetic field? What about the magnetic field? You don't know the answer to that, right? So what's the strategy that we follow when we haven't learned something? It's not the answer, right? Don't pick it. Okay, so we would say in this case, we wouldn't say that the magnetic field is not correct just because we haven't learned about it. Like, if it's not correct, it's not correct. Right? And it's not. But I promise you, if it's an answer that you need to include, I will have taught it to you. Does that make sense? If I haven't taught it to you, I'm not saying you should just leave it off because, oh, he hasn't taught it, so we won't include that one. No, if I haven't taught it to you, it's not the answer. So we're not going to include the magnetic field here. We would say just gravity and electric field, which is option 5 up here. Option 5, gravity and electric. By the way, the magnetic field would be inversely proportional to R, not to R squared, but to R. Does that make sense? It's an inverse relationship as opposed to an inverse square relationship. But that's okay, you don't need to know that. But just so you know that, in fact, even though you haven't learned it, it wouldn't be the answer even if you had learned it. Okay? And the last part of it says, is directly proportional to the distance squared. Well, we know that this is not directly proportional to the distance squared. We know that this is not directly proportional to the distance squared. And we haven't learned anything about the magnetic field strength. So it can't be directly proportional to the distance squared. If we needed to know that in order to answer this question, you would have learned that. So it's not the answer. That means, well, if the electric field, gravitational field, magnetic field, none of them are related to the distance squared, that means the answer would be for this one, 8. Yeah. How many people said 7, 6, 5, 8 for this one? Okay, good. Now, those of you who said that, were you thinking what I just told you? Like, were you thinking, oh, I haven't seen an equation that describes magnetic fields, so it must not be the answer? Okay, good. Okay, that's the way we always want to think. If we haven't seen something, then, again, it's not just that we're excluding it because we haven't learned it. It's just that I would have taught it to you if it was required for you to know to answer this question. So it can't be the answer. All right, quiz number 14 tomorrow.